You've got me, Hugh Carroll, CMO with 42 Crunch here as your MC. It's great to welcome you all today to the webinar. The topic is obviously a very hot one as we have a great number of registrants. So we hope to make it as engaging as possible for you. And Colin, our presenter, is going to give us a live demo as well as part of the session. So next slide, please. The session today is going to be presented by my colleague, Colin Domoney. Colin joined the team earlier this summer, and his role covers API security research and developer advocacy with 42 Crunch. Colin, he won't like me calling him this. He's an industry veteran, having previously worked with end user organizations and providers. So he has a unique perspective from both sides of the table. He's experienced with Cyberproof, Veracode, CA, and Deutsche Bank, amongst others. But he's also editor of the industry's favorite API security newsletter from APIsecurity.io. Before I hand over to Colin, just some quick housekeeping rules for you all. You're all muted. You can submit questions at any time via the chat, but we will hold the questions till the end because we want Colin to be able to present and deliver the demo before having to worry about questions. The recording will be shared afterwards as usual, so we'll be sharing a link afterwards to the recording. And there will be a number of polling questions for some audience participation, so don't be shy. Please vote. Don't vote often, just vote once, but please be sure to join in the participation. So the first question is here on the screen. I'm going to push a poll to you all. And really, it's just hopefully to give Colin a feel for where you're all at in your API journey. It's a single answer poll, so only one choice, please. But give it your best shot, even if you're not entirely sure. So hopefully this will work. I'm just going to launch the poll now. So hopefully you can all see how many APIs, both internal and external, are deployed in your organization. So single choice, as I said, less than 50 APIs, 50 to 500, more than 500, or you just don't know. No answer is wrong. No answer is, reflective of anybody. It's just giving us a perspective on everything here. So I'm going to let folks a little longer there. Okay, we've got over 76% of you, nearly 80% have answered. So, okay, I think I'm gonna end the poll there and publish the results. Share results. So, Colin, can you see those results there?
Yes, can.
Great. So, I mean, it's interesting. It's a good spread. Obviously, about 20% of you don't know, but the rest of you have pretty even spread, though the middle tier there, 50 to 500, is probably more to the front. But that's a sizable number of APIs, and obviously some of you very large deployments, over 500 APIs. So that gives us some context of where everybody's at that's here on the call today. So if there's no more comments, Colin, I'm going to hand over to you to take over.
Thanks very much, Hugh, and welcome to everybody, and thank you for taking the time to join today. So quite a packed agenda. The demo hopefully is going to be really interesting and illustrate this quite novel concept that we've got toward using automated API protection. So the agenda, just going to talk about the challenges with scaling security. So, the promise of DevSecOps, what does that look like, and why are organizations still in 2021 battling to scale their DevSecOps programs? And then fundamental to what we're doing with security as code for APIs is the concept of everything being based as code. And we're going to have a look at some industry best practice and patterns that organizations are using to codify the entire security via code. And then we'll get into the technical details of the 42 Crunch solution. So how our firewall product works and how we can do that to do security protection, and then how we do the injection, and then wrapping up with the use case and the benefits of this approach. So what are the challenges to scaling software security? So what is DevSecOps? And as Hugh alluded to, I've been doing this for quite some time now. I was doing DevSecOps before it was DevSecOps. And what I've done there, it's not wildly original, but what I've got is a working definition of DevSecOps. So I'm sure folk have seen that figure of 8 diagram with all the tools at all the places, lots of inject points, You've got SAST, you've got runtime protection, you've got monitoring, you've got alerting, you've got pen testing. And really the takeaway from that is DevSecOps is everywhere. DevSecOps is present everywhere around that software deployment cycle. And these definitions of things that make for a good DevSecOps solution, it needs to be well integrated. It needs to be continuous and automated. And that really is going to be one of the big takeaways for folk today, is to see how fully automated you can protect your APIs. So there'll be no manual steps. Everything can be automated. And in that opening question, there's a couple of folk on the call with very, very large API deployments. So that ability to centrally orchestrate is extremely important. The solutions need to be low latency. They need to act as to enable delivery and not get in the way. We're going to look at some. We're going to see some issues with security solutions that act as blockers. That's not the way to do DevSecOps. And basically, security is omnipresent and everybody's responsibility. So let's have a look at challenges around people, process, and technology. So what I've tried to do here is make an attempt to model a couple of ways that DevSecOps, is it Sec DevOps, is it DevSecOps, is it DevOps Sec, and let's go down from basically from worst to best. Obviously the worst scenario is you don't have a security team. Back in the day, I remember when people used to just develop and deploy software without any security. And as organizations become conscious of security, they either do the second or the third pattern. They'll either put security processes in place, which tend to act as an impediment and block their release process, right? And this causes lots of friction. Development complain that security is getting in the way, operations are late with releases. And what happens, of course, is people just circumvent and jump around that security step. The other way that people implement security is they do it very late in the day. So security work kind of at the same stage as operations when you've deployed. The problem here is security is happening too late. It's too expensive to fix problems. The attendant problems that we're all familiar with doing security too late. With scaling of your security, one of the patterns that seems to work quite well, and most people seem to be kind of hovering in that block 4, is to co-opt your development teams to become security champions. So this is about enabling your developers to self-serve their security requirements. And then ultimately that will evolve into a process whereby security is omnipresent, right? We've spoken about security needing to be omnipresent. Your security is involved at all phases of that development lifecycle. And that's the nirvana, that's the promise of DevSecOps. So API is a growing challenge, and we're going to look very quickly. So Hugh mentioned the API security newsletter. This is a weekly newsletter I publish. And I've just highlighted that pretty much every week, and this is a continuous pattern that we see, there's some or other breach or some other vulnerability relating to API security, right? And when we trace back and we look at the root causes of these problems, it's something like that. It sits in a people, process, technology sort of triangle. If we look at the people problem, we've got a lack of skilled API developers. So a lot of people who are coding and writing APIs are people who've come from another background. They've come from a web application background. And APIs are uniquely challenging in the way that they're constructed, and in particular, the way that they can be attacked. We have an OWASP API security top 10, and we have an OWASP top 10, right? So this is a challenge for developers to code APIs. And that leads into the second problem. Developers tend to be unaware of some of the sophisticated attacks and threats against the APIs and the way that skilled attackers can attack the APIs. And then the real problem, and when we're talking about what we're going to be talking about today, is being able to automate security injection, is we have a lack of security professionals. Right, there's not enough qualified, trained, skilled security people to be able to help keep these APIs secure. If we go over to the process, DevSecOps is not sufficiently developed or matured, so people are still sitting in that second or third stage. They haven't reached that fully integrated DevSecOps process. And then technical, a lot of the tools that we're using to try and do API security aren't suited to API security. And then the APIs are deployed incredibly quickly, right? Everything is now microservices, everything is in a pipeline, everything's thrown out with Kubernetes. There's lots of APIs, and we're not testing these things fully. Here's the idea of that code via your OpenAPI specification. That's central to how we secure APIs. So let's take some other industry examples. If people are familiar with infrastructure as code, I think this is a well-established paradigm whereby people are building infrastructure. People are familiar with tools like Ansible, Terraform, Chef, Puppet. The idea is that you can express your infrastructure in terms of network, application, storage, security, and cloud infrastructure via code. So you can write code, and then you can simply run these through a transformation, Terraform, and you can instantiate your running instances. Right. Before we did this, what we used to do was we would manually build servers. We'd manually tweak and configure servers. And what problems did we have there? We had a number of problems. We had servers that were deployed with risk because they weren't configured properly. We had configuration drift. We had people logging into servers and manually changing things. So the idea of infrastructure as code, it allows us to build immutable infrastructure that can't change, and infrastructure that can simply be reinstantiated when it breaks. Something goes wrong, you just rebuild your infrastructure. So, and a lot of those benefits, and I picked that off an article that I found online of the benefits of IAC. And when we look at the end of this demo, we'll see that many of those same benefits apply to being able to do API security as code. Main things are the speed with which you can do it, the fact that you've got reduced risk, the fact that it's scalable, right? And the fact that it's consistent. People can't omit to implement a firewall rule in a deployment because it's simply code. You can't skip that step, right? It's when you run your Terraform, your firewall gets deployed. You reduce that human error.
Colin, I could just push that poll now before you go
Sure.
to the case study, if that's okay. So,
yep, absolutely.
Folks, apology for the interruption. I'm going to relaunch a poll here, and hopefully you'll be able to see in your screens now the question. So it's essentially, who in your organization is primarily responsible for API security? Now, there may be overlap between teams, but we're really trying to get you to think about who is the main responsible for API security. And again, one single choice. There's no wrong answer. It's just to get a perspective for everybody and context for the presenter. So votes are coming in thick and fast. So development teams, security teams, API team, external folks, or no one in particular are the options. Okay, over 75% of you have voted, so I'm just going to end the poll there and share the results. So maybe Colin, you'd like to have a look at that? Can you see?
Yeah, so that's very interesting. So nearly 40, nearly half of the respondents are saying that the development teams are responsible, and the other people say that it's security teams, a quarter of folks. So very, an interesting result. I mean, this is good because what we're going to be showing here is a methodology that allows development and security to work closer together. Great. So another one of the use cases or the examples that we have from industry is GitOps, and then this is Weaveworks, the main proponents of GitOps. If people aren't familiar with that, there's a link, you can go and read about this. The idea here is that you express you do your operations via the means of a Git repo. So any changes to infrastructure are all orchestrated, governed, controlled by a Git repo. So if you want to build new infrastructure, Kubernetes is the best example here. You simply make a change to you do a commit to a repo, or you do a pull request. Somebody reviews that pull request, runs some automatic linting on it, checks it, says, yep, that's good. They approve the pull request. The moment that pull request is approved, your changes are pushed, and then you have a Kubernetes or something that is keeping your deployment matching your desired state, right? And that's all done via code. So how does this work in an API world? So APIs, we have a unique advantage, right? If you think about web or application security, APIs have one big factor in their favor. We have a specification. APIs are driven from code, right? If we are familiar with working, as I'm sure we are on this call, working with Swagger or OAS specs, we're familiar with the specification and those inherent benefits. So that's something I pulled off swagger.io. And I thought, right, what are the benefits that we get from working with the design first, with the specification? And we know we can do mocking, we can do implementation, testing, virtualization, documentation, deployment runtimes. We can write client stub libraries. We have auto documenting, tools. And the one thing that interestingly in that list is omitted is security. And that's what 42 Crunch are doing. Our philosophy is that we use that OpenAPI contract as the means to drive your downstream security. So we provide an audit tool, which provides obviously auditing and linting of your OpenAPI spec to make sure that it's high integrity and high quality. We can scan your running infrastructure, so your backend implementations, to check that they match the implementation. And then particularly what we're looking at today is we have a micro firewall product, which acts as a policy enforcement point, which makes sure that any transactions coming in and out of your firewall, your API, match that contract. Okay, we'll move through this quite quickly. So if we look at the elements of an OAS spec, so we've got obviously the green there, your paths, so your endpoints, and then we've got the data model. And then we've got, as a subset of that, we've got security. Now, in security, we've got the three domains: authentication, authorization, and transport. Now, 42 Crunch in their firewall product, they provide a number of security extensions. So firstly, they enforce the basic principle with the firewall is it enforces the contract. And we're going to look at this just literally in a second. We're about to hit the demo now. We enforce that contract, which means that anything that isn't specified is blocked. And this is what we call the positive security model, right? So it's an allow list. We're not trying to guess like a web application firewall is trying to guess what bad traffic is. We know because it's not in the specification, right? So we can give you a very pure enforcement of that contract. We can also do things in the firewall like JWT validation, and we look at that in a moment, right? So you specify the format of your JWT. You can enforce things like the algorithm, any of the parameters within JWT. You can enforce that via the firewall. We can do rate limiting. We'll see that in the demo. And we can do security headers. So we can enforce certain headers. We can strip other sensitive headers. And we see that as well. Right, so these are all things that we were able to do in the micro firewall. Now, before we move on to the demo, just the concept, and I think if there's one takeaway from this presentation of what we're doing, I've tried to represent that there. Let's imagine you going down a journey where you have an OpenAPI specification. Your API team or your data team has helped you, help the product team construct the initial specs. So they put in the information around the paths, they've defined the endpoints, they've defined the data models, right? So you've got a candidate OAS spec. Your development teams don't necessarily know what your security requirements are, right? They may not know what endpoint should I rate limit, what should my JWT policy be, what am I doing with my security headers? So the idea is that you're able to produce a working OAS spec, which has your data constructs in it. And then by means of security injection, you can downstream in a CI/CD process, you can go and inject those security parameters. And what that ends up producing is a fully specified OAS spec, which has those security controls in it. Right. So the idea is that it's transparent to the development team. So the development team don't have to be concerned about what the security controls that they need to apply for that organization. Those will simply get injected in line downstream. The development environment, I'm basically just going to be using Postman. I've got an application deployed in a container over on the right. I've got the unprotected version of that container running on port 8090. And then I've got the firewall version deployed on port 80. And what I'm going to do is I'm going to illustrate different behaviors from that. And then what we've got is we've got just a tiny little Jenkins pipeline running, which is doing a kind of pseudo build. I'm deliberately not redeploying the application because what I want to demonstrate is I don't have to change anything in the application. All I'm doing to build in those protections is simply by applying some annotations to the OpenAPI spec. And then I'm hitting the 42 Crunch security platform. We look at that briefly, and then we're able to re-inject those controls into the firewall. Okay, so let's get to the demo. So I'm just going to actually, before we do that, let's just take the third poll question. That's a good time to take that. A lot of this approach is contingent on organizations having an OpenAPI spec. And I know this is one of the challenges toward really scaling API development. So how are people on this call doing this? Are they starting design first and then code? Are they doing a mix of code and design? That seems to be the most prevalent in the industry. People iterate around that. You may be not using specs at all at this stage. And then the other common one is people just using the Swagger tools just to kind of reverse engineer from the runtimes to reverse engineer their spec. So if people could just pop down the most likely answer to that.
Yeah,
I'm hoping that it's mostly 1, but I'm suspecting it'll either be 2 or 4 that'll come out on top.
Well, interesting. I won't I won't bias the poll.
Yeah, don't lead the witness.
Okay, folks, we've got about nearly 70% voted. I think I'll close the poll now and publish the results and share results. Can you see that, Colin?
I can, yeah. So it is predominantly the mix of code and design, and that's probably about right. I think a lot of these tools are also getting better at helping people work around that to get that loop closed. And actually, there's content on 42 Crunch how we recommend for different frameworks and languages how to do that. And then a quarter of people are design first, which is great. And fortunately, only 3% aren't using specs. So, yeah, about what I would have thought is the case.
Okay.
Excellent.
Thank you.
Right. So let's now hit the demo. So I'll come back to the slideshow in a second. So let me just and I'm just going to go off screen. I just need to make sure I've got sessions with my platform. So might be a second to get myself logged in again. Okay, let's come back into. Okay, so what I've got running is I've got on port 1890, as I said, I've got an application running. This is the DevOps slop. Well, I can't remember the OWASP project that it's called Pixie. And what Pixie is a little node application. So it's running on that port 1890. So what I'm going to do now is this is the unsecured, so there's no firewall in place. So this is the application. Now what I'm going to do is very quickly whiz through and show a couple of vulnerabilities in this application. So I'll log in, I'll get a session, and then what I'll do is I'll go and get my user information. So I'm going to show you a couple of issues with this. So firstly, we notice we've got no rate limit on the user info. So I can just keep thrashing away at this, and there's no rate limit on that. The second problem we notice is I can seem to list all the users, but unfortunately what I notice is in that user listing, I'm pulling back the passwords, right? So what I'd intended to do is produce a summary review, but I've unfortunately included passwords. If I try and that's an OWASP, that's excessive information exposure, right? We're giving away too much information on that return. The other thing I try and do is I try and do mass assignment. So what I'll do here is I've got a call to be able to edit user info, and I just guess, and I say, oh, I'm sure if I just put is admin is true, let's see if I can update that user. And yeah, the user successfully updated.
Sorry, Colin, just to interrupt you there. Sorry.
Yes.
I don't know if it's possible to make the screen slightly larger.
Yep.
the settings are probably optimized, but just maybe slightly. But if folks can watch this on a large screen, it's probably helpful.
Yep,
But
that should be better. Yep.
Yeah, thank you.
Okay, so what's happened there is that's mass assignment. So I've been able to guess a user variable, and then it's accepted that. So there's a number of problems. The other thing that we've got is we've got an excessively long timeout on that token. You know, it's I'm obviously not going to sit and wait for an hour for that to expire, but you know the token is very long lived. So there's a number of issues. The other thing is we're doing something a little bit bad. We're also leaking some implementation detail. We're leaking back that we're running Express, right? It's Node.js, and we're telling so that's that's gold dust to an attacker because they know what framework you're using. So application unprotected, we've got a couple of problems. So let's have a first stab at fixing this. Now, what we've done is in the design, we've built this with, so this is the 42 Crunch platform. I'm not going to go into a lot of detail on this, but let's just, for quick summary, what I've done here is I have, and there are plenty pre-recorded webinars on some of these features on the product. We've got a spec on this, and what I've done is, in the specification, I've constrained some of the data. So we're going to look at some of those issues that we saw previously and see how just by constraining the data, we can control some of those problems. So let's have a look at the transaction log. So we have now a firewall instance. So I've got a single instance running. So we'll go back over to Postman. Sorry, this does come kind of thick and fast. Now what I'm doing now is I'm accessing that same machine on port 80, right? So I will go and do a login. Sorry, I need to register first. So I will register. I will do a login. Right, I'll get my user information. So the application is behaving exactly as expected. I'll click away at that and I'll see I've still got at this point, I've got no rate limiting in on that. Right, so I haven't fixed that because I haven't attempted to. What I have fixed is I've fixed that being able to expose excessive data. Right, so what's happening is now at the firewall level, I've got a 502, so I've got a bad gateway. It's been able to, it's invalidated, it's got an invalid response, and we look at that in a second. The other thing I'm going to try and do is I'm going to try and do the mass assignment. So I'll do mass assignment without injecting the password, and we'll verify that works. Right, and then what I'll do is I'll try and inject, and forbidden, I got a 403. Right, and it's coming from the firewall is detecting that. So let me flip back over to the firewall and we'll see what issues we found. So people can see what's happening there. The firewall has interpreted the request and seen that in the request body, there was an additional parameter is admin, and it's blocked that request. And the same thing with the listing the users. The firewall has noticed that the users weren't defined in the response body, so it's rejected that response. And if we go and look at the OpenAPI spec that we've got for that, I'll show you what that's looking like. So the first issue is the all users is returning user list item, right? And if I go and look what user list item looks like, I should only be able to see email name and account balance. So nowhere in there is password. So what's happened is the firewall has enforced that contract and said, look, the thing was supposed to have given me an email, a name, and an account balance, and it also gave me a password. So it's been blocked at that point. And then the other one was on the is admin, exactly the same thing. So that's edit info, and so to edit the user info, we should have taken an email, a name, and an account balance. And of course, what we did is we added in that extra parameter. So that's the firewall basics working, which in itself is, just by specifying your data correctly, you've already achieved quite a significant level of protections. But it gets better than that. We'll go and have a look now how we inject protection into that pipeline. So we have a pipeline that is looking like, and let me show you what the pipeline is doing. So it's just our friend Jenkins. We pull down the code base, and I said I'm deliberately not redeploying the application because I don't want to do any smoke and mirrors here and pretend that and actually make the changes in the code. I'm not changing the running application at all. I'm only doing these fixes with the firewall. So I just echo out the build step. I reconfigure I run a plugin to inject some controls, and we'll look at these controls in a second. And then I redeploy the firewall, and then I pretend that I've run a fake deploy step. Right, so let's build that and let's run that. Right, and that all worked well, and we go back to the platform. And we should see, yeah, just a moment ago there, 1632, we've redeployed the firewall, right? So we've reconfigured the firewall. And if we go and have a look at that security editor now, we'll see that we've injected, right? You can see there, we've got a number of 42 crunch specific headers. We've put in rate limiting. So after, in a 10-second window, you allow 5 requests. And we'll come to the JWT in a second. But let's now go and have a look at what that looks like again. So we'll try to log in again every time. All right, let's get a registration. We'll get a login. So we're still working properly. We'll go and get the user information. Now what I'm going to do is I'm going to click away at that. Right, I've got a 429, too many requests. So I've been hit with rate limiting. The other thing that I forgot to show you here, I know we did show you the responses. So let's just look at the get user information. That X powered by Express. So let's go and have a look at what that user information looks like now. We look at the headers, and that header's been stripped, right? So we're not leaking that implementation detail. One of the other things that I'd mentioned is we have a very long timeout on those on the lifetime of that token. So we'll go and see that we're still able to log in. And we're going to see in a moment that, so I hit my 429 again. Let's go and have a look what the platform is seeing in terms of what's actually happening on that API. Right, so we're able to see here, we're seeing the 429, the retry window, and hopefully by this stage we've now, right, so we've now got a 403 forbidden. We go back to the platform and we refresh that. Right, and what we've now got is we've got a restriction on the token lifetime. We've only got a 60-second window on that token. And I'm going to try, this is sometimes hard to demo because of that 60-second window, but what I'm going to do is I'm going to go and log in again, and I'm going to quickly grab that token, and I'm going to force the session to use that token. And I'm going to get that user information. That should work. And what I'm going to do is I'm going to go and deliberately tamper with this token. Right. Right, and we'll go and try and get that user information again. And we've got a 403 on that, and we go and look at the message on the platform. Yep, it definitely isn't a JWT because I've gone and manually messed it around. I mean, you can do this in the application, but I've done that in the firewall, and I've actually, well, let's have a look at the implementation of that. So the way the injector works is it picks up some protections. So I've told it to do the rate limiting, and I've told it there's where it's being told to strip these headers. So we've got a control there, an annotation that says remove headers. So we've gone and stripped those headers out, and that's all been injected automatically. And that's the JWT validation. And then I can also specify there the lifetime of that JWT. Right, so that's all been done without having to change the application, and actually without anybody having to do anything. The only thing I did to make that all work was I ran the Jenkins build. That's all I did, right, to make that work. So let's just conclude very quickly with a summary on where we are. So the use cases and benefits. So there's a number of deployment models, and I'm hoping that I'm going to get good questions on this, because there's a number of different ways people can use this. So I've sort of gone from the most reactive to the most proactive, and these are use cases that I've got. So one of the scenarios is something happens, I've been hacked. There's a new attack emerging, and I need to put some controls in place. I'm using I've spoken about using implementation libraries that have exposed complexity. I've discovered there's an admin endpoint in one of my APIs, and I need to block that thing ASAP. So what you can do, if you have the firewall in place in front of all your instances, you can simply deploy a new runtime firewall rule that says /admin block that regardless of that. So immediate responsiveness, and something that can scale, obviously assuming you've got the firewall in place in the first place, you can scale and you can respond instantly. You can also respond to emerging threats. If you inherit legacy APIs where you're unable to redevelop and redeploy the application, I showed there, I'm protecting an old version of Pixie, which is obviously deliberately vulnerable, but I didn't have to change the application at all. I could go and protect that by just changing the firewall in front of it. It's defense in depth, right? It's allowing you to do your defense in multiple places. If you wanted to change policy, an example there would be you decide that you need to reduce your JWT token validation timeouts to 60 seconds. You can do that centrally. The central governance, that you can do your governance in there's a single point of enforcement via the 42 Crunch platform. And then if you're developing new features or bringing new development teams on, it's an easy way to kind of graduate them and bring them on board, and enable them to understand, how to be implementing security and what controls they should be looking at. Those benefits are, the scale is the main one for me. The fact that, imagine if you had this issue, if you had to change 500 API endpoints, and you had to go and do each one of those deployments manually to implement rate limiting. Whereas with this, you can simply do that by reconfiguring 500 firewalls, which is literally a one-line script. The fact that you can centrally govern, the fact that you've got a single policy enforcement point. Segregation of duties, I normally get the question on this is, don't we have some kind of conflict here? You said that security is everybody's responsibility, but shouldn't security be upfront? Whereas by injection, you're actually doing this later in the life cycle. The point is that it's segregation of duties. It's allowing the developers to focus on their endpoints, the data contracts, the functionality of the API, and it's allowing security-minded people who are more cognizant and more aware of how the API should be behaving from a security point of view. It's delegating the security contract to them, but you don't have to operate it like that. You can do a hybrid model where you could do, for instance, the JWT validation. You could do that. That could be a development function, whereas your rate limiting could be a security function. And then most importantly, it reduces that human error. So, what are one of the most common vulnerabilities in APIs at the moment is people add an endpoint and they forget to secure it, right? Unauthenticated endpoints. With that injection as code, you can simply go and annotate and inject the requirement for validation on every single endpoint, and you can enforce that in the firewall. So I think a number of benefits to that. I think we're going to take Q&A at this stage.
Yeah, that's right. There's a couple of questions coming in, and folks, the Q&A function at the bottom of your screens will allow you to submit text-based questions. So you might want to leave up those links, Colin, actually.
I will do. I'll come back. I just want to answer this question by showing the...
So
I'm going to answer that live. I don't know what that does. Now, I don't know if people can see the question. The question is, are the firewall rules injected into the OpenAPI specification of the app, or is there separate firewalls? So the way that works is, if I'll show you the... No, that's not the right thing. So what I've done in that inject stage is, yes, on the 42 Crunch platform, I've actually I've injected into the, so yeah, to answer the question, yes, it's in a composite spec that resides on the 42 Crunch platform. So it takes your OAS and then it injects these additional security controls, and it goes and annotates. Let me find an example of where it's done the annotation. There. So on user edit info, it's gone and injected a local strategy right on that endpoint. You don't, what's happening here is it's not rewriting that OAS at source, right? It's only injecting it into the firewall at runtime. I hope that answers the question. I'm going to mark that down if it doesn't.
That's right.
But then obviously what you can do is, once you know what works for you and you've tested it out, you can take these rules and then go and put them in at your source as well. So I'll mark that as done. What is the additional latency? So I don't know if we publish latencies. Let me show you. It's milliseconds, I believe. Let's have a look at a request analysis. That's not it.
I think this is a common question, in fact, and
Yep.
it's one of our kind of strengths. Even the word firewall sometimes provokes, fear amongst people. But be assured, this is a very virtualized PEP, and it's microseconds, I think, so to milliseconds. So it's
yeah, so three milliseconds on that, and you can actually see it does the full analysis of what it's doing on that matching. It's gone and tried to do the validation, and it's kicked out here on the dot validation. Let's just pick another one. Too many requests. Let's see what that looks like. 2 milliseconds. Yeah, and I mean the point here is that you can actually speed up sometimes your backends, because if you're able to do the validation and the enforcement in a firewall, or what is effectively a highly optimized, micro-coded, hand-coded implementation, you can often do that type of validation quicker there than in your own code. So I'll mark that as done. And yeah, so what happens if the firewall blocks something that should not be blocked? Who can resolve a false positive? Yeah, so I'm gonna say that's, you haven't defined your contract correctly at that point. I know that's, from the end user experience or from a test experience, that might not be desirable, but the intent here is to drive a fully correct OpenAPI spec. Right? If you don't have that, then lots of things are going to go wrong for you downstream, not only your security. Right? If your documentation is based on an OpenAPI spec that is incomplete or incorrect and doesn't match the implementation, you're going to have other problems. So the behavior we're trying to drive here is to make sure that that spec is the single source of truth.
Sorry, Colin, go ahead.
Yep.
I was just going to jump in there. There's a couple of questions relating to API management gateways. So, one is this tool an API management gateway, or is it more than what one expects from a commercial API management gateway? And what I would say there is, we're oftentimes deployed alongside API management gateways and indeed web application firewalls. In fact, I think something like 80 to 90% of the enterprise customer deployments we're in have already got those services or tools implemented. So what they see 42 Crunch is providing is a dedicated API security platform in addition to their existing tools, because those existing legacy implementations or tools are not fit for the task of automating and scaling API security. So we're not to be confused with an API management gateway. You might see some overlap in some of the functionality. However, we are an API security platform, and that's a dedicated category now. And if you guys want to find out more, there's a couple of links here. The first two links here on the slide are two industry analyst reports covering this space and how they see the technology evolving. So really good landscape insights on both of those reports there, all available from the 42 Crunch site. Are there any other? There's a load of questions coming in. I don't know if time-wise, what we might do is go back to you all individually. There's some questions also, Colin, on the chat function. As
No, I
opposed
see. I can just pick off some of those quickly.
Yeah.
So
Okay.
to Deepak, does the firewall need to be enabled all the time? Yes, it does, right? So you inject, it's a one-off operation to inject the spec into the firewall configuration, and then the firewall will be running all the time, yes, to be able to enable those protections. And then how's the firewall deployed? So it's deployed, the demo that you saw, it's two containers running via Docker Compose, but typically we deploy it as a sidecar. That's our typical deployment. We've got models and patterns to be able to use Kubernetes injectors to kind of make that API injection, the firewall injection, seamless into your deployments, because we realize that that's one of the issues that people are going to have if we're asking people to deploy micro firewalls. There's work involved there, but we're going to leverage your the Kubernetes, the power of Kubernetes to be able to do those highly scaled deployments. So it generally sits as a forward proxy. It sits on a listening port, intercepts requests, and then forwards on. What else do we have? How much network traffic can your firewall handle? Because it's operating on an individual API, I assume I don't have numbers to hand, but it's obviously designed to be much the same as the latency question. I'm not sure if we have published performance figures on how much traffic and what volume, but obviously it's not acting at a gateway level. It's operating on individual APIs, right? So it's not it's not being designed to be managing your whole sort of organization sort of proxy. It's running on an individual API.
Great. Okay, Colin, I think if there's any other questions, folks, I see one or two more. What we'll do is we'll get back to you directly. And what I would say is for further reading, follow these links. If you're not subscribed to the APIsecurity.io weekly newsletter, I would really encourage you to tune into that, because it's a weekly newsletter edited by Colin, which is a vox pop across the industry, looking at all the latest breaches and fixes. So it's a really useful resource. And finally, if you want to play with some of the tools, we are the #1 OpenAPI editor tool on a number of the major marketplaces. So you can go to VS Code Marketplace or JetBrains or Eclipse, and you'll find some of the tooling there. So again, you can follow the links from our corporate website to find things. So listen, thank you all for your time today. I hope you enjoyed the session. We'll be sure to share a link later. So a number of you have asked, we will be emailing out a link to the recording. And we hope to see you online soon for the next webinar. All the best. Thank you. Thank you, Colin.